to first pre-process the text data and then turning them into meaningful numerical representation. And we'll be dealing it and starting with this library called as Natural Language Toolkit, or also called as NLTK. It is a popular Python library used for natural language processing to work with human language data, and it helps convert text into numbers with which the model can then easily work with. And NLTK has tools such as tokenization, stemming, tagging, parsing, and sentiment analysis. So all these things will be really helpful because our machine learning algorithms can work only with numbers, and being the text data, we need to do some pre-processing methods which helps us to combine and convert them into meaningful numerical representation. So to install this library, we can go with pip install NLTK and we can import NLTK. It's the library, and this NLTK has supportive things as well, which won't be available at the beginning itself. So you have to download by passing the name of it every time, or if you want, you can simply call download all so that you can go error free in the later part. So we'll go into our Google Colab, and we have a sample text for our practice as well. So let us start with pip install. If you don't have, you can go with pip install NLTK, and then we can go with import NLTK. We can use NLTK.download all. So download a specific, for example, we have something known as Punkit, which is going to download a certain set of tools. It will be hectic when you try to utilize it. You will be getting a lot of errors in between that it is missing, then you have to download at that particular time. So it's better to download all at a moment. So if you pass this, it is going to collect everything and download and keep it ready for you for the later part. So moving into the first technique, which is tokenization, which is one of the very basic technique we used to do for our data. So what is tokenization? Tokenization is the process of splitting a text into smaller units called tokens, and we'll be doing some process to split our text into tokens. So once you have them as tokens, these tokens could be like they could be individual words or phrases or sentences depending on the specific task at hand, what you have or what you are planning to do. And by breaking a text down into its constituent parts, we can begin to analyze its meaning and structure. And for example, this sentence tokenization is a particular tokenization method where if you have a paragraph, what you will do is you will turn them into different sentences. So a sentence ends with a full stop, so it is going to separate there and give you a list of sentences. You will be getting a Python list. So see here we have a paragraph on our left side, and when we apply sentence tokenization, it is going to split it into parts. Like space is the vast three-dimensional expanse where objects and events exist. That's a sentence. So you get another token. So this process happened and the output we used to call it as tokens. So we have a token. Now this paragraph is turned into tokens or 4 sentence tokens. Similarly, you can, if you want, most probably in our process we will be interested on word tokenization, where we will be turning everything into individual words. So if you have a paragraph, you can turn it into word tokens, which is individual words separated by comma, or in the meantime you can also convert them into like from sentence into words. That can also be done, so you don't want to worry about its form. You can use word tokenization to turn them into individual words. And why we used to do is each word has a meaning, so we will try to convert later on, right? So we need to extract information. So the first process is creating tokens, so you can conquer, divide and then conquer. That's the methodology. You split them and then you apply your methodologies or process to convert into numbers or do the pre-processing as well. So you can use NLTK to perform sentence tokenization or word tokenization based on the task at hand, and you can go with NLTK.sent_tokenize and NLTK.word_tokenize to perform this tokenization either into sentences or into words. So I hope this is downloaded now. So with download all, we are going to do something like, for example, we have our sample here. First let me call the sample and let us see what do we have in hand. So this is our sample paragraph, some paragraph about some basketball team. I don't know, just a sample text. So what we are going to do is we are going to call NLTK dot sent underscore tokenize. So if you pass your sample inside, it is going to turn them into tokens, which are a list which is separated by comma. And if you want, you can store it. We'll store it in sentences is equal to this. And if you look at the length of sentences, you will get how many sentences you have in your paragraph. You have 8 sentences and it's a Python list. So you can access them with the help of index number. Maybe index 0 will give you the first sentence. Index 1 will give you the second sentence and so on. This is the first sentence. Then the next will give you the second sentence. Then the third. Then the fourth and so on till you have 8 sentences totally. So this is sentence tokenization, and if you wonder, you can also perform the sentence tokenization without this library. It's pretty much simple. You have to use your Python skills. So using Python, what we can actually do is, if you call for example sample.split, and if you, it's a string method, so you can mention where you are wanted to split. I want to split wherever I have full stop, I want to split it. So if I run this, I'll be getting wherever that's a full stop has been reached, it is going to separate them with a comma and split them into individual tokens. This happens, so you can use either this or that to achieve this. This is sentence tokenization, to turn them into sentences. Mostly we will work with word tokens because we will split them into words and then apply some process which we will be dealing later in this session. So to start with that, let us do words is equal to NLTK.word underscore tokenize, and if you pass the sample or your sentences here, you will be getting individual words separated by comma. So if you look at the words now, you will get all the words separated by comma. So this is a list of all your individual words, and we can also look at the length of words. So the total amount of words we have is 156. So that's the number of words you have. Even a full stop or any punctuation will also be considered as a word. So now we have a word tokenized. So now you have each of your word in your sentence or in your paragraph. You can apply your processing, which we will be dealing now. And this can also be applied. If you look at the sample, you can just call split, and earlier we gone and split it at the full stop. If you don't pass anything, it is going to split wherever it has spaces. So it is once again going to give you the same result wherever a new word is coming or any new word is there. Like if you reach a space, it is going to separate with the comma and it is going to give you. Now we have our words here, right? So anywhere, if you want to combine them once again back into a sentence or into a string, if you have a list of words or a sentence, what you can do is you can create an empty space like this and call dot join. It's a string method. You are calling an empty string and joining, and what you are joining is you can pass your list. It could be words that will be joined back, or if you want, you can back once again turn from sentences into this. So they are, every sentence is now separated with a space. If you want to see this change, maybe if you look at the words, we are leaving a space between every word. Maybe if you have another space, you can see the difference. Now all the words are joined with 2 spaces. Now with 3 spaces, that's what the join will work. Maybe if you want, you can add triple stars. So it is going to be like, this is what the join will do, and leave 1 space to get neat results like the paragraph earlier. So these are the process with our sentence and word tokenization. So what is stop words? As the name itself suggesting, we are going to stop these words. So what are these? Stop words are words that occur frequently in a language and they do not carry much meaning on their own, such as the, yeah, and so on. So we have a lot of stop words, a collection of it for each language. It differ, and for English especially we have it. And stop words are often removed. Why? Because during the pre-processing, to reduce the amount of noise and focus more important words in the text, and these words are available in NLTK stop words, and they can be used to remove in our data set. So we will be using the library like what we used for sentence or word tokenized from NLTK. The same library we are going to utilize for this particular task as well. So these are some of the examples of stop words. We have I, me, my, myself, we, are. So we have a lot or bunch of them. So let us go and see what all stop words we have. So we can actually import from NLTK.corpus. We can import stop words, and with the help of this we can actually work with it. So let us go into our Google Colab and I have some sample sentences here. Let me run this. So I have a sample and I have something known as data, so which we will be using later. First we are going to be interested in something known as sample. So first let us see what we have in the sample text. So it's a paragraph. Okay, so we have a paragraph. It seems like something about blue whales. It seems like it's a basketball game and a team name, and we have some content about it. We are not interested in the content, we are interested in processing this. So before taking that, we will import from NLTK.corpus. Let us import stop words. So in this stop word, what you can do is you can call stop words dot words, and you can pass like the language. So we are interested in English, right? So if you run this, you will be getting that. And yeah, as we have discussed earlier in our previous session as well, so we will be required to download some things. So for now we'll just run and download the stop words, and later on when we go into the content we'll start running all, so that it will download all. It will take its time, but still it will be downloading all. So once we move into the content theory parts, we will do that. So first I'll import NLTK, and then we can go for NLTK.download. First we'll just download this alone, stop words alone. So whenever you use, please make sure you do it so you can use it without any issues. So what do we have here? We have a bunch of stop words available. It is a list, and you can actually check the length of it as well. So we can store it in stop underscore words is equal to NLTK. Okay, it is, we have already imported to stop words dot words of English. So with this, let us first check the length of the stop words, how many stop words we have. 179 stop words is available in NLTK, and for this NLP process there are other libraries as well, which is alternative, which if you are interested you can use that. So the final process we are going to do the same, tool changes, okay, but the final thing which we are going to achieve is going to be the same in both. And here especially when we try to remove stop words, we can also remove any punctuation. So we know that we have some punctuations available, right? Maybe if you look at your data, which is, I hope it is called a sample, right? So the earlier sample we were discussing, so this has punctuation marks as well. So if you are not interested in punctuation, we can pre-process that as well. We are just considering the words for now. So we can actually import string, the inbuilt module of Python, and if you go and call string.punctuation, you will be getting all the punctuations which is available, all the characters. So we can simply store this. We can just create a variable called as punctuation, and let us store this. And with these things, what we can do is before continuing, we need them in tokenized format. The word should be tokenized. So let us go and call NLTK dot word underscore tokenize, and we will be passing our sample inside. So we'll be getting a list. Okay, it's first we'll download this, later on we'll go with download all. That's a better way. So for now we'll download this, and we'll see the sample. So we have tokenized the word, right? So yeah, so this is our tokenized. So I'll just go with words is equal to, I'm storing it. So what I'm going to do is I'm going to just iterate through it. Every word in my sentence I'm going to iterate through it, And then what I'll do is I'll check whether it is a punctuation or a stop word. If any one of that clicks, okay, we are going to remove that, okay. Or if a word which is not present in both punctuation as well as stop word, then it's an important word which we need, so we will be storing that. So I'll create a new list, new equal to a new list, and what we are going to do is we can just go and utilize for loop for x in words. So the words are our data, right? We have tokenized them into words. From that, every word is taken. So if x not in stop, okay. So if your word is not in your stop words, okay, then this will return true. At the same time, I will be using AND operator and check another condition here. X not in punctuation. So if both are giving true, then that means the word you got is not a stop word as well as it's not a punctuation. So we can go with new dot append and we can pass the particular word X. And now if you look at X, you will be having a list of words. Okay, this is not what we expected. For X in words, first let us check the words now. Okay, we have everything and we have our stop words as well. And I think this AND operator is not working properly. We can just enclose this in the bracket. So finally it will check whether both are true and then it will proceed further. So when we run this and check our, okay, the problem is till now I am trying to print this X, but I need to check the new, right? So the last entry is a full stop. That's why we got that issue. It's my mistake. So we have this new variable. So that's what we should check. And what we have here is the new words or the words which will be removed based on stop words and punctuation. If it is not in there, this is both going to return true and we get that. And if you want, you can look at the length of this. So now after this processing, the word count is 81. But if you look at your words which you had earlier in your sample, it is 156. So nearly you have reduced the noise into half by taking only the important things and neglecting other words. So if you want to combine this, okay, so this is fine. We will be using them as word tokens. But in any place, if you want to combine them, what you can do is you can use, if you have a list, you want to combine them into a string, you can create an empty string like this with some spaces, and then you can use dot join and you can pass your sentence words list of words here. So every word is now separated with a space and then it will be joined. So this is what after processing, after removal of stop words and punctuations, if you look at your sample, this is what your sample looked like. Okay, so some of the word just has been removed, there has been removed. You can see some of these persist, some of these has been removed, and that is a removal of stop words. So after stop words removal, we have our list which is new, which has all the words, which is important. So that is the use of stop words, and we use punctuation as well to ignore that and all. So this is one way of pre-processing, so which we prefer for stop words. And especially there is some thing which we also keep in mind, that when we go with stop words, sometimes it can remove some of the stop word. There are some stop words or some words which can carry some information, and accidentally if the stop words has removed it, then we will be actually losing the information. So it is suggested to start with stop word, and if you find a situation where your model is not performing well, you have no idea about where the leakage might happen, you can negate the stop word or remove this process of stop word and proceed without that to see whether there is an improvement or not. But it is suggested to remove the stop words when we move towards the projects. So moving into the next pre-processing, we are going to discuss about stemming. So stemming is another important process, but we won't prefer stemming much. Stemming is a base thing, and then we have something known as lemmatization next. So we'll be going with any one of this, not with both. First, we'll see about stemming. So stemming is the process of reducing a word to its base or root form which allows different variations of a word to be treated as a same word. So why do we do this? Once again, we are trying to reduce the complexity of our sentences or our words. For example, the stem word of running, runner and runs is actually run. So stem is the base word or root word you are going to predict that. In English, we have this tenses, we have other stuffs, right? The suffixes like running, runner, runs, studying, studied, and all. So this we are trying to reduce to its base form. And stemming actually what it does is, if you have some words like this, it is trained on this process so that it removes the suffix. Okay, so the stemming knows that it need to remove the suffix like ing or er or s. It is going to just cut it off. But the stemming don't know whether the resulted word after cutting off, you will be having the remaining word right in the beginning. It don't know that whether it is a proper word or not, or a perfect real word or not. For example, stemming is actually not always perfect, and it can sometimes result in the stem of a word that is not a real word or is not the correct stem as well. For example, the stem word of was will be wa, which is not even a real word. Also, you can see we will be getting some problems like this. If you look at the stemmed word of study, it will be studi. Again, studied will also be termed into that. So that y is changed into I, and in studied the same. Studies is also es is removed. So it just know it has to cut off the suffixes, but it don't know what meaning the resulted word is going to be. So it don't know that process and all. So it just cut it off and give you. So that is stemming, and we don't mostly prefer this, but let us see how to imply as well. So this you can take from your NLTK.stem. You can import porta stemma, and with the help of this we can actually stemmatize a word or stem a word and get the resulted word. Next we'll see lemmatization. Before that we'll just imply the stemming part. So we'll go into our Google Colab once again, and this is fine. And for example, we can go and import first from NLTK.stem. Let us import from NLTK.stem, import porta stemma. So stemmer is equal to, I'll create an object, porta stemmer. So it's better to go with the object. And first let us do it manually. Stemmer, you have the option of stem, and let us pass a word called as running. You get the word run. So if you pass inside stem is a command for stemmatizing, and if you want to like turn them into a stemmed word, what we'll do is we'll just call stem and pass the word inside. So for running it looks fine, it looks great. We'll do it for was. You will be turned into wa, which is not a real word. And if you look at studying, you get study with I, or study, the word itself you get study. This is not what we prefer anyway. So instead you can also look at this. Maybe we'll first do it. So we have our stemmer now, right? So stemmed words is equal to empty list, and I'm going to use for t in. Maybe we call our for n and new. Okay, we will pass stemmed words dot append. We are going to add it in the end, and what we are going to do is we can call stemmer dot stem, and let me pass the word n inside. So after running, if you look at the stemmed words, you will be having the words which is stemmed. Maybe if you look at the joined word, you can understand. So we'll join it into a sentence and see this. So you can see played. I hope it was played earlier. If you look at the base, maybe if you look at the sample, we can understand it. So the blue whale played has been turned into play. First, baseball. You can see baseball is not a real word here. L is missing there. Believe is changed. Excite is excited is changed. It just cut it off. It don't know that semantic meaning here. So that's why we prefer the ultimate next step, which is the lemmatization, which is better than this. Okay. So this problem was like stemming was the earlier version. The idea wise it was good. You are reducing the complexity, but the achievement was bad. Right. Anyway, it's half. You can get some words good, some word was not good. But if you go with lemmatization is the process of reducing a word to its base form, which is called here as lemma. That's a stemmed word. Here it's lemma, and lemma is actually going to be a full word. So the lemmatization is similar to stemming, especially, but it produces a valid base form of the word that is found in a dictionary. So which is a real word it is going to give you. So the output of lemmatization is a word's base form or lemma, which can be a real word or a root form of a word. Here you can, if you pass this after lemmatization, you may get an entire word, a word which is complete, a word which is not something like a not available word and all. So we can use the lemmatizer from NLTK. We can go and use stem, and we can import the wordnet lemmatizer, and we can do this process. So for doing this, we'll go into our collab and let us continue now. So what we are going to do now is first let us import it. So from nltk.stem we will import wordnet lemmatizer, and we'll create an object lemmatizer is equal to wordnet lemmatizer. So we can call lemmatizer. Here it is lemmatize. Okay. So the function to convert is lemmatize. So if you pass study in, you get study. Okay, we have to download it. So I think it's better now to wait or just run this command, which is download all, which we should have done earlier. So we will go with nltk.download all, and in between we'll discuss at the same time. So you can pass this all. Actually it will take some time, that's why I have negated to do it later. Anyway, we forgot it. Some of these things should be downloaded. That's the difficulty of NLTK. But what you can do is whenever you start your collab, if you just go with import NLTK and then call download all, so it is going to download everything, and we can just go smoothly without getting any error. These are not errors. These are missing packages or missing things, which once everything got downloaded. So instead of going one by one, so if we install this, then later on in the next process we will get other issue. So it's better to do it in a single step, and yeah, so it will be completed soon. So these are some processing. So if you look into it, first we had a set of paragraph. Your data will also, it is completed. See here, your data will also be something like a paragraph. So you turn them into tokens or word tokens, whatever you call it, single individual entity. You then remove the stop words, pick the important words alone, or then we can go for lemmatization, especially stemming. We have this issue of not a complete word, right? So we can go for lemmatization, and first let us run this. Now it will be fine. We won't be getting error. So this is giving us studying itself. Maybe if you look at study, eating. Okay, so this is not exactly converting it though, right? Maybe first we'll imply this and see. Maybe in the larger complex text it is going to perform. So let us go with for, okay, we have done it earlier, right? So for stemming, we'll do the same thing for here as well. Let us go for doing the same thing here with lemmatized word, lemma words, and we are going to pass it to our lemmatizer, and this should be lemmatized. Yeah, so now if you look at the lemma words, we'll join and see it. Okay, is there any difference? Let us see with dot join our words, which we have used it as a raw material here for running. Okay, new, right? So new is After stopwatch removal, we had that. Wales played first baseball game. And regarding lemmatizer, the problem will come, this way, especially like this will come, especially in a scenario where actually we need to understand how this lemmatizer work. Earlier we have done stemming, which actually cuts off it, right? So the cuts off it, it will cut off the second half or the suffix and all. But looking into the lemmatizer, it will lemmatize considering the word, and it tries to lemmatize it, and it will understand or take it or treat the word whatever it get, it is going to treat the word as noun. So if you know what is a noun or pronoun, we have adverb, verb and all, right? So it is also called as parts of speech. So that is involved here, and by default your lemmatizer is going to lemmatize the word, thinking that it is going to be a noun. For example, if you try to lemmatize a word, let me do something like, we call our lemmatizer to lemmatize something known as runs or rocks. Okay, you will get rock, so that is removed here. Especially if you have some other different word. For example, if we try to do something like, let us do it for the lemmatizer dot lemmatize. If you try to do it for running, we get something like running itself, because it is treating that as a noun. But if you pass it as a verb, you will be getting a run here. So we may need to fine tune in that way as well for our process here. And if you ask me, how should I know what it is? Maybe you are weak in English. You don't know what is, maybe for example, whether running is a verb or rocks is a noun or a pronoun, or what should it be. I don't know what it should be considered. So what we can do is we can actually use our NLTK, and we can call for parts of speech underscore tag. Okay, so you can pass a word. For example, let us pass something like car, and let us get what we are getting. Okay, so we need to pass it as a list of string, or we can pass our words. You can see it is giving you NN, which is actually noun. And you can check for some other word. For example, let us do it for fruits. Okay, so let us give a name, for example, Elon. Okay, and then for example, he. Okay, it's a pronoun. So like that we will be getting. So how can I integrate it here? Because we can't manually do this, right? So for that, what we can do is we can create a function in Python. Let us go for NLTK, like tag finding. And since we have, you will be getting this as not in a short form, not an enhanced form. So this will get the tag. So you can just get the tag, and what we can do is if our NLTK dot okay, NLTK underscore tag, right? If it starts with like, you may get J, which is for like return. We can just go with, yeah, we will also import this word nut. So from NLTK dot corpus, let us first import the word nut as well, and from this we can get, okay, so word nut dot adjective. If it's J, that's what it is, so we can pass that. Or elif your NLTK underscore tag starts with something like, let us have some other word, for example V. So if it starts with V, then we can return wordnet dot, it is a verb, so we can pass that. Elif NLTK, okay, here I made a mistake, this is NLTK. So NLTK underscore tag dot starts with we have noun, and if you have that, just return wordnet dot noun. And elif NLTK underscore tag dot starts with, let us pass R, so it is for adverb, so we will return wordnet dot adverb. Or else I'll just pass return noun. Fine. So this is a function which is for conversion. So now how are we going to integrate this? So first we'll do some function which is called as define Lemmatize sentence or words, Lemmatize underscore, and we'll first get maybe we can do it for word. So Lemmatize underscore word, get all the word inside. So once you got it, you can get the tag NLTK. Tag is equal to NLTK. We know if you pass post tag and if you pass the word inside, you will be getting the tag of it. So from that tag we want to get map, right? So we need to get it back, and you know that this will return a tuple like we got here. So it is inside of the 0th index, inside of that first index. So we need to take it. Okay. So for that we'll write a lambda function simply. So where net tag is equal to, so we will go and just map it by calling a lambda function of x, and this will be getting x of 0 comma NLTK. What's the function name we had? Tag finding, right? So in that we will be passing our x of 1. So that will do the task, and then finally here we'll pass the NLTK comma okay NLTK underscore tag. That's what we will be expecting, and first we'll try to do it. So if you pass Lematize underscore word, let us try to pass for a word known as running. Okay, we are not returning or printing anything, right? So first we'll print wordnet underscore tag. Okay, we are getting, since we are mapping it, maybe if you do it a raw version, you will be getting it. Okay, running, and it belongs to VBG. Okay, so it starts with this. So we return verb. That's what we are trying to map now. Anyway, so we'll map it, and then simply what we can do is we can also do the lemmatization here. So I'll create something known as lemmatized underscore sentence or word. Okay, why to do many steps? I think we can simply do for the entire corpus. So here when we get a word, instead of we can do it as lemmatized corpus, and what we are going to do is here we get the entire paragraph, or let the name be word, but okay, words or something like that. We can go and turn this anyway using NLTK dot word underscore tokenize. So we pass the entire thing. We'll do it here itself. Why to pass many things? So it will be now turned, and now we can imply. So we can start with for, since we have mapped it. So for word comma tag in wordnet underscore tag, what we can do is we can check if tag is none, then we can simply just call the lemmatized. Okay, here lemmatized words, right? Lemmatized words, we can call append that word if it is none. Okay, lemmatized, yeah. So else we know that it has a tag, so we can ask it to lemmatize based on it. So it will be done lemmatized underscore words dot append. We can call the lemmatizer dot lemmatize, and we will pass the word and its tag especially. So this will be done. So finally when I try to return, okay, so once everything is completed, let us return this dot join and return my lemmatized underscore words. And now if you just pass your entire thing, maybe if you try with lemmatize corpus, and let us try with our, what do we have earlier? Do we have a sentence? I hope it's dot join our new, and if you do it, it has now turned it. You can see the difference, especially here what we had, it was as such when you just do it rawly, Okay, it need to understand what is the parts of speech as well, so we create automation for it, and whatever we get we are trying to map it as well. So this is what after lemmatized, this is what the result is going to be. And you can see it has been cut shorted. At the same time, the words are completely available in a dictionary, not a word which is not even a real word. And that is about lemmatization. So this is the difference between stemming and lemmatization. You know, stemming is easy, but it will return a word which is not even a real word. But when you go into the lemmatization, we will be, if you use these parts of speech as well, especially, it is going to give you nice results which we expect. So that is